Section 2.6, Derivative Rules. Constant, sum, difference, and constant multiple. So we are going to add 3 more properties or rules to derivatives. Actually, this is 2 rules, but it's really the same. We'll talk about it. So if I want the derivative of a constant means the derivative of, like, say, 3 or 4. What we have to realize there, well, the slope of a flat line of 3 or 4 is 0. So any flat line is 0, and that's why the answer to constant is 0. Next, if we take a function, plus or minus another function, we basically are just taking each derivative one by one. The plus or minus means whatever the first piece is, take its derivative. Whatever the second piece is, take its derivative. And whatever the middle sign is, plus or minus, just leave it. So basically we're taking the derivative of each piece one by one. That's all that's saying. Lastly, if we take the derivative with a constant in front, all right, what happens is you just leave the constant and take the derivative of the function. You just leave the constant sitting out in front. Kind of the limits. You did the same thing with the limit. You left the number in front, didn't touch it, took the limit, and then left it just sitting out there. But that is a rule that you are allowed to do. And these are the rules that we're going to build off of, and the power rule, leaving that on too. So we're going to take the derivative of this big old thing. Well, isn't this using 1, 2, 3, this property? Meaning, aren't we just going to basically take the derivative of this piece, and this piece? According to this rule, we just take one by one. Now before we do that, let's rewrite this. This is really saying d dx, and derivative, of 3x to the negative second, plus 6x to the, what power would this be? Well, the root is 4, and the 3 goes on top, minus 5. All right, so we rewrote it first. Now we apply this, so we're going to take the derivative, each one by one, and for each one of these we're going to do power rule, except for this one, we're going to use this constant rule. So watch this. The answer is going to be, well, wait a second, there's a 3 in front here. We're also going to do this rule. With this 3 in front, doesn't that say just take the derivative of f and just leave the 3 out front? So what that's saying is we're going to leave the 3 out here, and don't we put a negative 2x, and let's be careful, negative 2 minus 1 is negative 3. That's easy to mess up. So again, we left the 3 out front and took the derivative of this, and there we go. So the next piece, this one. Are we going to take the derivative of this, leave the 6 out front this time? All right, so leave the 6 out front. We're going to put the 3/4 out front. This is going to be x to the drop the power by 1. Want that to be negative 1/4. Be careful there. It's pretty easy to mess that up. That's negative 1/4. All right, so that would be this piece. And then what's the derivative of a constant? It's 0. So my last piece would be minus 0. So this right here is my derivative, but we can clean this up. So let us clean this up. Let's see. This right here, what's that going to become? So this is going to be 3 times negative 2 would be negative 6, and the x to the third can go to the bottom. So for the next one, won't the 6 and the 4 reduce to a 2 and a 3? And if we multiply the top, won't that become a 9, and the bottom is a 2? And then this right here, won't that go to the bottom because it's negative power? So won't that be an x to the 1/4 on the bottom? And then lastly, can we just leave that off? So my answer is this. It looks kind of ugly. We could try to get common denominators, and we will deal with that in the future. But for now, I'm just going to leave my answer as negative 6 over x to the third plus 9 over 2x to the 1/4. And you could again put this back into a radical if you wanted, but that right there is a good enough answer, and we'll go with that and talk about simplifying things later at times. So let's take the derivative of this one. Well, none of these properties talk about multiply. So what do we do when we have a multiply? Well, can't we just change its form and then apply these rules? Oh, yeah, we can change the form. What I mean by that is, can't we just distribute? So don't we really have the derivative of, well, what's the square root of x times the square root of x? Isn't that just x? So isn't that just going to be 3x? And the second point, isn't that going to be plus 4x to the 1/2? Now, why did I go x to the 1? Where did I get x to the 1/2 from? Well, isn't this time this 4 square root of x? Isn't the square root of x 1/2? And isn't this a better notation for taking derivatives? So again, square root of x is an x, so 3x. And 4 times the square root of x is this. So let's take the derivative of this now. All right. So we're going to apply the power, not the power rule, we're going to apply this rule right here. So we leave the 3 out front, and the x to the first, wait, what's x to the first? Isn't it be 1x to the 0? Wait, what does that equal to? Won't that end up being x to 0? Isn't that 1? Isn't this 1? So won't this really just be 3? Yeah. And that's another rule, which I didn't write there, but technically, isn't anything with just an x going to just be that number in front? Because think about this. Isn't that a line with the slope of 3? So this one is going to end up becoming just 1. So let me just jot that down. This is just going to become a 1 here. Well, that's just going to be 3 times 1, which is 3. Awesome. All right, let's keep going. So plus, what's the second part going to be? Well, I leave the 4. I bring the 1/2 out front. I drop the power by 1. All right. So when I do that, won't this give us 2? So won't this become plus 2? And won't the negative 1/2 go to the bottom, so I can leave a square root down there, or a 1/2 power down at the bottom. So I have this answer. Now, this one I'm actually going to simplify just to practice. So by the way, again, this is an okay answer. But what I'm going to do now is I'm going to multiply top and bottom by the square root of x. There's a 1 here. And when I do that, don't I get 3 square root of x plus 2 over the square root of x? Can we now add the tops because the bottoms are the same? And this is a better answer for future reference. There's going to be reasons why you want to use this different answer. And so I combined and simplified this one a little bit. And this would be an answer. This right here in the blue is also an answer. I just want to show that. Now here we could do the same thing. We could get common denominators. This one just got a little creepy, and I didn't want to mess with that one.